Now the phase diagram that we were seeing in a previous video has lots of information in it that's really good for understanding what's happening with matter. But realistically speaking, most of you are unlikely to deal with high pressure bells or vacuum chambers and all these changes in pressure. That said, there is a reasonable chance that some of you may end up making some sort of a pasta dish, which I will leave vague, at a high elevation. Some of you may end up going to Colorado and deciding to eat some pasta. Or maybe you're making a cake. Either way, we'll want to know a little bit about what the pressure around you is going to do to things. Now, if you're at high altitude, you're going to be at a reduced pressure. Now, if you're at a lower pressure, water is going to boil at a lower temperature. So here's our vapor pressure. We can see a couple of different solvents here, water being the one that we care about in this circumstance. If I drop to a lower pressure, let's just say that I go down a little bit. Oops. My water may be boiling at 95 Celsius instead of 100. That may not seem like a really big deal, but if it's boiling at 95 degrees Celsius, that means you're cooking at a cooler temperature, 95 degrees. And if you just lost 5% of the temperature that you were cooking with, you should expect a longer cooking time. On top of that, if you're working with something frozen, like frozen corn, and you're putting it into your recipe, you probably want to thaw it and drain it first to minimize the amount of ice you put in there. Because now you're really increasing the cooking time by having to melt the ice, melt the frozen corn, and cook it. So you're probably going to have things cook unevenly and you're going to end up with a real mess for your dinner. What if you're at a higher pressure? Well, your boiling point is going to be higher. In fact, look at how dramatically it shoots up. Now suppose that I put a cap on my pot. I can probably get my temperature up pretty quickly. And in fact, if I do that, I can end up cooking my food a lot faster. That's the basic idea behind a pressure cooker. So what a pressure cooker really is, it's just a pot, and it's got an airtight lid that you put on it, and you lock into place. Okay, that's a great looking lid. Here we are. We'll just call that the lid. Now right here is going to be a little spout where the steam comes out. So what you do is you take a little, 3-pound weight or 1-pound weight or whatever pound it is. It's got a little needle on it. You set it right there in that little thing. So basically this thing is sitting on it. The steam's gushing out. It's going to take a certain amount of pressure to make this, basically levitate in the steam. So basically this is acting like a hovercraft, and the weight of it pressing down means that you have some pressure. By increasing the pressure in here, you've increased your boiling point, and now you can cook your beans a lot faster. And often I mean a lot faster. Sometimes instead of soaking for an hour and then cooking, you can finish the whole thing in 10 or 15 minutes.